Okay, so today we are going to cover the review for test number 2. For test number 2, if you guys are in the in-person section, which is section 01, you will take it on Monday, April the 5th, at the same time as class normally would be. You will have 60 minutes to take the test, regardless of when you start it. You can start it anywhere from 30 minutes before the class period through 30 minutes after the class period. But whenever you start it, you'll have 60 minutes to take it. So make sure you allocate yourself that block of time. I mean, it is your class time, so it shouldn't be an issue. If you are in the W01 section and you're in the online section, then the test opens at midnight on Monday morning and remains open through 11:59 p.m. on Tuesday evening, which is Tuesday the 6th. If you are in section 02 with Dr. Hussein, then the test opens 30 minutes before your class, which is a Tuesday-Thursday class, and that is on the 6th at about, I think your class is 6:30 to 7:45, so I think it opens at 6. But either way, you should be able to see it in D2L right now, so you can see the time. So make sure that you don't forget to take the test during your appropriate time, because there are no makeups on these tests, as you know, hopefully. All right, so I'm going to run through the requirements, and then I'm going to go through a practice test with you guys. So these are the same rules as the previous time. All answers must be your own. You're not allowed to talk to anybody. You're not allowed to listen to any kind of music or any kind of recordings. You cannot have any audio going on in the room with you while you're taking the test. You must be at a computer that has a webcam. The webcam has to be able to see your face. The room has to be appropriately lit. You have to be there for the entire time. You cannot get up and leave the room for any reason and come back to the test. Once you start the test, you have 1 hour. Once the hour is over, you leave. You'll be taking the test in D2L, the same as you did for test 1. It is in lockdown browser, so as soon as you open up D2L, lockdown browser will start and you will go through the normal process of checking all of the normal things that lockdown browser does. You must have your KSU ID with you when you take the test, because at some point it's going to ask you to show it. If you don't have a KSU ID, make sure you bring a driver's license or some other photo ID with you. We are going to ask you for your net ID this time. I'm sorry that we changed the rules on this from the last time. Last time we asked you to enter your KSU ID. We actually need your net ID. And this is because we have to export stuff from one system to another. And it turns out that you can't export the KSU ID out of one thing or the other. So your net ID is the beginning of your email address. So my email address is esully13 at kennesaw.edu. Yours is whatever the first part is before the @students.kennesaw.edu. So that's the part that you need to know. It is printed on your KSU ID. So make sure you have that with you. If you don't have it, it's not the end of the world. We can probably match your test, but it just makes it easier for us to match it if we have both of that information. All right, so while taking the test, no resources. You're not allowed to use any other computer. You're not allowed to use a phone, a smartwatch. You're not allowed to have headphones in. You're not allowed to use a tablet. You're not allowed to use another computer. You're not allowed to use a book. You're not allowed to use paper. You can have nothing with you other than you and the computer. Same rules as last time. You must stay in view of the camera the whole time that you're taking the test. All right, so the statement that's written up here is in the middle. Anyone who violates these rules will receive a 0 on the test and could be reported to SCAI for cheating, which will result in a 0 grade not being replaced on your final exam. All right, so the rules of the class are, if you get a 0 on either test 1 or test 2 for a reason that is not deemed a cheating problem, your final exam will replace test 1 or test 2. If you take test 1 and test 2, then your final exam will replace the lowest of those 2 grades. If, for whatever reason, you are deemed as a cheating case because you got up or you used something that you were not supposed to use during the test, it will stand as a 0 on your grade. All right, so don't cheat. That's the simple answer. All right, you will only have 1 attempt to take the test. You must do it for the full amount, so make sure that you have a 60-minute uninterrupted block. And you have to code everything in C# or Java. No pseudocode in your answers. There were a couple of people in the last test who fell in and out of pseudocode through the answers. You cannot do that. It has to be regular code. You will not have use of Replit or any other IDE while you're taking the test. I'm sorry, that was the final decision on that. The reason is because we actually had some people during the lab whose computers locked up because apparently there's some weirdness between D2L and Respondus and Replit, where we had about 5 people whose computers just locked up in the middle of the test and were not able to complete it. So we're not going to do that in lecture. We will probably still do it in the final exam for your lab because it's a different section. All right. Other than that, partial credit will be awarded as appropriate. Okay, so what I did was I took the actual document that is the test and I changed all of the questions. So this is the exact format of the test, and the questions cover similar material so that we can do an actual practice together and look at what types of things are covered and are not covered. You had a question here. I talked so long, I made you forget your question. Sorry.
Yeah, I did have a question.
Okay, well, when you come back to it, just pop your hand back up. All right, so this test primarily focuses on modules 4, 5, and 6. Modules 4 was GUIs and graphics, modules 5 was recursion, and module 6 is exception handling. We will be doing very little from module 4. As a matter of fact, there will only be one question, and you will not be expected to write any code from module 4. You will just be able to answer a technical term, and that's kind of what this example question is. What is the difference between a label and a text field? And so in a GUI, the label is something that you can write to and it shows information on the screen, whereas a text field is something that you can have the user type input into and see what the user did. You're going to get a question similar to that as question number 1. It is apparently worth 5 points. The point layout is the same on this versus the actual test. All right, so that is the only thing we're going to ask you in module 4. Again, it won't be these exact questions, but something similar. So you're not going to have to write any GUI code. Do not spend a huge amount of time memorizing all the ins and outs of GUIs. You just need to know the general concepts of GUIs and graphics. The questions that were on the quiz, that question, those are kind of representative. Yes, question? I can't hear. Say again. Okay, so the question was, will there be anything from modules 1 to 3? And the answer to that question is not directly, insofar as we're not specifically asking you a question from modules 1, 2, or 3, but of course all the knowledge that you have in there, like how to define a class, is still indirectly used in these methods. So we're not seeking questions for 1, 2, 3, but we will inadvertently ask you to write classes, which was something we covered in module 2. So that's the answer there. Okay. Question number 2 and question number 3 are going to pertain to recursion. Question number 2 is a tracing question. Question number 3 is a writing question. So you're going to have to trace some recursion, and then you're going to have to write some recursion. All right. So here is an example of something that you might be given in order to trace. So what we're doing here is we have a main method down at the bottom, which defines an array of strings. So we have string myArray equals new string. And then it is set up with a bunch of strings. The strings are Java, C#, C++, Python, JavaScript, Rust, and Ruby. All right, so it's an array of strings. Each one of the cells in the array contains a string. And then what we're doing is we're calling print on a recursive call to a method called trace, passing it that array and the number 0. All right, so if we skip up to the top here, we have public static string trace. And we're just going to talk through how you would go about tracing this. So again, you will not have paper while you are tracing it. What you will have is a text field in D2L that you can write anything you want into. So while you're tracing it, use the text field to trace, and then just erase whatever you need to erase at the end of it. All right. So the method was called with this string and the number, or the array of strings and the number 0. It starts off and it says, if 0 is greater than or equal to the array length. Okay, well, the array length is at this point going to be 7. So 0 is not greater than or equal to 7, so the if condition is not going to happen. So now we're going to go into the else condition. All right, so the else condition says return array at position y, a carriage return, and then the recursive call. So effectively what you need to be keeping track of here, if I use my little magic pen, so you're going to have a call where you are passed the array and the number 0 in the first call. And what we are doing is we're making a call that says return the first string, because the first call, y is equal to 0. So the array at position y is right here. And so array at position y for the first time through the iteration is going to be the word Java. So it's going to return Java plus whatever this recursive call is. So the recursive call passes the array again, and what does it actually pass? It passes, it passes y plus 2. So y originally was 0, and so the second time through, y is going to be equal to the number 2. All right, so that's what your first call looks like. It is important to remember that if you are adding something together, you need to keep track of what it is that you're adding to each recursive call. All right, there is also a carriage return in there after the word Java, but that's not important. I have a question in the room. Yeah. So you can type that line in the bottom of the box, and then you can erase bits of it and type in whatever you want. So you can absolutely do it in a text field. It's not as easy. I'm not arguing that point. It would be easier if you had a piece of paper, but you have a text field, so get used to using a text box, basically. When you're done, make sure you erase everything out of the text box other than the actual answer, because we don't need your entire stack trace in your answer, all right? Okay, so we were past the array, and this time the number 2. All right, so in this case, it is going to return, again, 2 is not greater than 7, so it is going to return the array at position 2, which is 0, 1, 2, which is the word C++, followed by a carriage return, followed by the recursive call with the array, and this time the number 4, because it's adding 2 to it each time when it makes the call, y equals 2, or y plus 2. All right, so this time we now have another call, and it takes in the 4 and the array, which the word array is going to get less each time, and it's going to return the 4th cell. So 0, 1, 2, 3, 4 is going to be JavaScript. Plus the recursive call, this time with a 6 in the recursive call because y plus 2, the array plus 6 this time. All right, and so once again we go through, 6 is not greater than or equal to 7, so we're going to make at least one more call. So we are going to get our array 6, and that one's going to return 0, 1, 2, 3, 4, 5, 6, which is the word Ruby, plus another recursive call, this time with the number 8 as the y value. All right, so finally, we're getting towards the end. We have the array and the value 8, and now we're going to look at our code again, and we're going to realize that 8 is greater than or equal to 7, which was the array length. So finally, we've hit our base condition up here, and so we are now supposed to return the array at length minus 1. Well, the array length was 7, so minus 1 is 6, which is position 6, which is the last cell in the array. So we are going to take out the last word of the array, and that's what it's going to return. So this one ends up returning Ruby. Okay? And so now we're going to just start filling that in. The word Ruby gets filled in here. That string gets filled in here, that string gets filled in here, and so on down the stack. So in the end, what we're going to get is Ruby, a carriage return, and then Ruby, because there was a Ruby here as well. And then you're going to get JavaScript plus this. In actuality, it will end up being in the reverse of what I'm reading, because the very last one will eventually return Java plus everything that came from the next one, which will be Java, C++, JavaScript, Ruby, Ruby is going to be the final output, because as they get filled in, you're adding to the end of the string. All right, so the final output of this method would be Java, C++, JavaScript, Ruby, Ruby. As they pop off the stack, that's how they will get filled in. Does anyone have questions on this? This is slightly more complicated than the one that's on the test, but relatively similar. Yes? The array when I passed in 8, 8 is greater than 7. That's a greater than or equals check up at the top. and so it returns array length minus 1. The array length was 7. 7 minus 1 is 6, which is position 6, which is the last cell of the array. So it does return a valid number. The 8 doesn't cause an error in this case. Is that good? Yeah, all right. Any other questions on tracing? Okay, so you're going to have something similar to this on the test where you're going to need to trace a block of code that is recursive in nature. It'll either have numbers, doubles, ints, or something. Most of the time when you're tracing, you're going to have some kind of a counter, which is what that y variable is doing up there in the header. And that's what's going to be used to get you towards the final condition. And then you may have optional other things that are moving in here, like the array in this case that you're using to keep track of stuff. So I will post this example exam to the D2L shell right after class in both sections. So you guys are welcome to go back and recode this. I would definitely recommend that you go back and redo it after class. Make sure that it makes sense to you and that you're getting the right answer from it. All right. Okay, so that is question number 2. Question number 3 is also going to be from module 5, and this is a recursion question again, but this time you're being asked to code a recursive method. So in your choice of language, C# or Java, write a recursive method which takes in 2 integer type parameters, x and y, and calculates the sum of all the first y numbers starting at x. Okay, that's a weird way of phrasing it. For example, if passed in 2 and 3, it would return 8 because it starts at 2 and then it's going to add 3, 4, and 5 to it because it's told to do it 3 times. So 2 and 3 would produce the number 9. There's a typo there, thank you much. 3 and 4 is 7 and 2 is definitely 9, don't know why that says 8. If passed in 4 and 2, it would also return 9 because starting at 4 and only going 2 numbers, 4 being the first number, 5 being the second, if you add those together, you also get 9. All right, so you need to write a recursive function that does this. Again, this one's a little bit more complex than what would be on the test, but it's still a good example for you to practice with. All right, so you're going to begin every if statement or every recursive call with some form of an if statement, right? So we're going to go up here and I'm going to make a new method. What does this return? It returns an integer. All right, so public static int and do it, whatever it takes in int x and int y. All right, and so what is the condition at which you're going to stop? So if you are given the second number, the y number, so I'm going to refer to them as x and y. X is the first number, y is the second number. X is the number we're starting with. So if we're going to do 4 plus 5 plus 6, x is going to start at 4. 4 plus 5 plus 6, we know we're doing that because the other number passed in was 3. So the y number is effectively a counter. You are going to count down or count up, your choice, but probably count down every time that you go through the recursion until you get to the end. When you get to the end, you know that you no longer have to do anything. So if they passed you in a 0, I think the answer would be that you would return 0, right? If they tell you to sum 0 numbers, the answer is 0. So that sounds like my if condition here. So I'm going to say something like, if y equals 0, then return 0. Okay? Say again? Yeah, probably should do less than or equal to. That's fair, because why are you not allowing me to type? Okay, weird. Yeah, because if they give me -1, it should also probably return 0. That's very fair. All right, so otherwise we have an else, and then we're going to have our condition. All right, so what are we trying to do? We're trying to take the first number, the x number that was passed in, and we're trying to add other numbers to it. So it sounds like my return is going to start with the x plus some other junk. So if they passed in 4 as the x, then I'm going to take 4 plus whatever the recursion magic will eventually add into that. All right, so now we have a recursive call. So it's going to be a call to do it. And now the question is, what changes? So yes, so the x variable is supposed to get bigger each time. We started off with the number 4, but what we want to add to it the next time is the number 5, and what we want to add to it the time after that is the number 6. So each time through the recursion, I'm wanting the x to go up by 1. So I'm going to pass x plus 1. The y variable is where I'm keeping track of how many times I need to do this. So the y variable seems to need to go down by 1 in order for me to hit that base condition. So I'm going to do y minus 1 as my second parameter. So let's do a sanity check after you've written this. So the first thing to make sure is your base condition going to get hit at some point? And the answer is yes, because I'm checking y got less than or equal to 0, and I'm making y get smaller no matter what. So if they gave me -1, boom, it exits. If they give me 0, boom, it exits. If they give me 1, it will go through once, and on the second time, boom, it will exit. If they give me 99,000, it will go through however many times, and eventually it will get to some number that's close to 0 or 1. All right, so let's give this a test and see where we are. I really don't understand why that's doing that, but okay, whatever. So we were supposed to say do it, and we were passing it 4 and 2. And so what we mean by that is we want to take 4 and add to it 4 plus 5, which should come out to, thank you. Is that what you were both about to tell me? 2 hands up in my pre-compilers. All right, and so that should end up being 4 plus 5, which gives me 9. All right, so you will be expected to write a recursive method similar to that, obviously not exactly the same as that. This one is just a smidge more complex than is the one on the test. But again, if this does not make sense, you need to go back and either rewatch this video, because it is going to be posted on my YouTube channel if you're in the in-person class or in the online class. And if it still does not make sense, you should probably ping me in office hours or send me an email about what doesn't make sense. But you need to be able to write this successfully. All right, so that is question number 3. Yes? Okay, I think the question was, my logic is telling me that the x plus 1 shouldn't work. So there's nothing about the x that I'm using to stop the recursion. I'm only using the y variable to stop the recursion. The reason I'm passing the x plus 1 is because in this particular function that they're asking for, I'm supposed to add the 4, then the 5, then 6, then 7, then 8. So therefore that x has to grow each time I go through the method. That's only true because of this particular function, right? If they'd asked you to do factorial, it would be a different thing. If they ask you to do power, it would be a different thing. So you have to look at what the actual method that they're asking you to do is to determine what the right thing to add or remove from any of the variables might be. Yep. All right, so to review, question, oh yeah. If I do not, okay, so the question is this x plus 1 actually necessary? Wouldn't it just automatically get bigger? And the answer is it will not automatically get bigger. Unless I specifically pass in something, the x would be the same each time. So if that plus 1 was not there, what this method would actually do is it would multiply the two numbers. Very specifically, if I gave it 4 and 2, it would add 4 to 4, and it would give me 8, right? Because x would not change. So if you were trying to write multiply, it would be do it x comma y minus 1, because the x wouldn't need to change. You good? Okay. All right, so question number 1, module 4, general definition. Question number 2, trace recursion. Question number 3, write recursion. That's going to be it for module number 5. Question number 4 is going to be a trace of a error handling or exception handling. And question number 5 is going to be a write exception handling. Okay, so, and that's it, that's the whole test. So question number 4, let's talk through what's going on here. And this is to test your knowledge of how the try catches work. So what it's asking is, what is the output of the following code? All right, so at the top here, we have a main, and the main is going to start off by doing a try, and it's going to make a call to has issues, which is a method. All right, so the has issues call for a method call is wrapped in a try, so it's going to catch some number of exceptions from that. All right, so has issues is up here, and so it's going to begin, and it's going to print out the first thing. So the first output from this is going to be place 1. All right, which is going to happen no matter what, because there's nothing that could go wrong yet. All right, the second line of code, we have double x equals 7 divided by 0. There is a slight difference between the C# and the Java code there, and that's simply because the C# compiler will not let you write that code. So you have to trick it. But anyway, so double x equals 7 divided by 0 is obviously going to throw an exception. what exception? It's going to throw some form of arithmetic exception, divide by 0 error. Okay, so at this point, the execution of this method is going to stop. And that is a very important detail that you absolutely need to be aware of. The moment that an exception is thrown, all code stops functioning and it tries seeking the catch block. So the print statement that is underneath here that says print place 2 is never going to print. Make sure that that makes sense in your head, because the execution ended the moment that that threw an exception. The exception sends us back to this try catch block. So the try catch block down here has 2 separate catches that could possibly fire. So the first one is to catch an index out of bounds exception or an index out of range exception. All right, so is that what we threw here? No, it's not. What we threw was some kind of arithmetic exception for a divide by 0. So that is not the right thing to catch. So that will not catch. So we will not get place 3. That will not happen. But the next one catches all exceptions. So it is catching exception, therefore place 4 will fire. So the final output of this method is going to be place 1, place 4. It is not going to do place 2 or place 3 for 2 different reasons. Place 2 because the code stopped executing the moment that we had an error, and place 3 never happens because it's the wrong catch for what was thrown. All right, so output of this method should be place 1, place 4. Questions? All right, I'll add in one final comment. What would be the output if there was a finally block underneath the catches? Well, whatever is in that finally block will then execute. As a matter of fact, if there's anything below the catch block, they would also execute as well. All right, so your code resumes after the catch blocks. Yeah. Okay, and so the question is, how did you end up breaking out of the method when the exception was fired? And the answer is, that's just how it works. When you wrap anything in a try block, if there is an exception, the code stops executing immediately, because if you did not catch that exception, the code would have crashed at that moment. So an exception by default will crash your code. If I did not have the try catch stuff at the bottom, then the output of this code would be place 1 and then a stack dump, because it would crash. And I would get some division by error or division by 0 error on the command line. So the try catch is what's allowing it to continue, but it does stop execution right there and then the moment that an exception happens, and it moves on to trying to handle that exception. Yeah. Okay, that's a great question. The question is, why would you ever use a finally block after a try catch if it's going to just continue after the catch anyway? And the answer is, it just makes it very clear that you are doing that regardless of whether the try happens or the catches happen. If you have a circumstance in your catches, depending on what went wrong, you may actually want to abort the code and stop. You may have to go and do a whole bunch of rewinding. An example I gave somebody yesterday in office hours was, if you're a bank and somebody actually tries to overdraft their account, you're not just going to print a message to the screen that says, bad user, you can't do that. You're actually going to go put the money back into their account, however much there was. You're going to probably send a message off to the fraud department telling them that maybe something weird has happened. There may be all this other code that has to happen in those try blocks. At the end of all of that, you may have a bunch of cleanup that has to happen regardless of whether the transaction went through or not. And that should probably be in a finally block, because it makes it very clear that it's related to the transaction, but isn't actually going to happen is going to happen no matter what. Make sense? Okay, so that is question number 4, and that is the output of a exception handling. Question number 5 is just broken up into 3 bits. So when you see it in D2L, they will appear as if they're 3 questions. So if you look at D2L and you see that there are 8 questions and you're like, he told me in lecture there would only be 5, you're being mean. It's not, it's really just that question 5 is 3 parts. They're all really short. So the first part is write a custom exception, which is something that you've done in lab, and it's something that you've done in some of the assignments as well. So in order to write a custom exception, you're going to define a class. This one's supposed to be called badstuff, badstuff.java, in this case, because I'm in Java. If I'm in C#, then you just put in the same thing inside a regular file. Class, really, class bad stuff extends exception. All right, so by itself, that is enough code to define an exception. It also tells you that you need to be able to handle a message that's being passed in. So anytime that you throw an exception, you can pass a message, a string, as part of the exception that's thrown. And you did that in some of the examples, like you had to throw exceptions for some of the particular stuff that you did in lab, and sometimes you want to put a message in there like it was too high or too low. So in order for your custom exception to handle a message, what you need to do is take the message from the user and hand it to the exception module, the exception class, which is above you. I extended exception. Exception has a message that is a built-in string that it knows how to deal with. So I need to put my message that the user gave me into the string in my parent. So the way that I do that is I call my parent's constructor. So I need a constructor in here, which is going to be public bad stuff. Constructor should look something like that. And then I'm going to just call super and pass it message. The message should have been passed in. So I'm going to say string message. Okay, so this is a constructor that takes in a string, and all I'm doing is I'm calling my parent and passing it that string. I'm calling the constructor in my parent. Honestly, 99 times out of 100, I tell you that memorizing something in class isn't going to help you. This is one exception, and it's an exception. How cool is that? So that's literally how you write a custom exception. If you can do that code that's on the screen, you're good to go. If you're a C# student, the only thing that changes there is instead of the word extends, that's going to be a colon. And instead of where I say public bad stuff string message, you would then, after the closing parenthesis where there's string message, have colon base parentheses message, and then open close curly braces, because you're still calling the parent. It's just to use the keyword base, and it has to be in the method header in C#, not inside the body. All right, questions about writing a custom exception? You guys have done this before. This should be cake. All right, so that one is worth 10 points. Next off, write a method get numbers, which prompts the user for 5 numbers. If the user enters 7 at any point, throw a bad stuff exception with the message zoinks. All right, so we're going to come up here, and we are going to go to the actual Java file, and we are going to write a method. Okay, that is just not working today. Public static, what is the method supposed to do? Prompts the user for 5 numbers if the user enters 7 at any time. All right, so public static void, do other stuff. All right, for int I equals 0, I less than 5, I plus plus, and then we are going to need a scanner in this case because I'm in Java. Really? Go away. Go away. Scanner myscan equals new scanner system dot in. Up here, I need to include that. Really. Import Java util scanner. Okay, and then I'm going to, inside of here, read in some number. So myscan dot next int, I guess, or you could read it in as a string and do whatever. And so int x equals that. All right, and then what we were supposed to do is if they type in a 7, we were supposed to throw an exception. So if x is equal to 7, that is not 7, that is 7. Then we are supposed to throw new bad stuff, and the message is supposed to be something cutesy. ZOINKS. Apparently I was watching Scooby-Doo this morning. Okay, so throw new bad stuff zoinks. All right, and that is pretty much that. That will ask for 5 numbers, and if they type in the number 7, it will throw an exception. All right, so you should be able to throw an exception. Obviously, this is kind of the question that was asked earlier. Are we going to ask you questions from modules 0, 1, or 2, or 3? And the answer is no, not directly, but, well, you still have to know how to write a loop. All right, questions on this one? All right, and then the last part of that question, which is 5C, is write the main method that calls get numbers. If any bad stuff exceptions are thrown, deal with them by printing their message. If any other exceptions are thrown, output bad things happened. So down in our main method here, I do have a throw in there. Oh yes, sorry, thank you very much. This is Java, so I need to say throws bad stuff. Good call, thank you. All right, down in my main method, I'm going to need to do this in a try block. That's the whole point of catching. So I'm going to say try, do other stuff, and then I'm going to attempt to catch bad stuff, and I'm supposed to print out something. If bad stuff exceptions are thrown, deal with them by printing their message. How do you get the message? Well, it's in E, which is that variable of bad stuff, and it's just called e.getMessage. In Java, it's just called e.message with a capital M in C#. All right, and so if that happens, I will throw that out. For everything else, I'm going to print some other stupid message that it tells me to do. Bad things happened. Okay, so that is a try block. So you can see in this one question, it is 3 parts. We're asking you to write a custom exception, which is defining the class. The second part, we're asking you to actually throw that exception in a block of code. And in the third one, we're asking you to call the method and handle the fact that that method or that exception could be thrown. So that's why there are 3 parts. They are related to each other. In D2L, they will look like they are question number 5, 6, or 6, 7, and 8, because again, it doesn't understand A, B, and C, weirdly. Okay, that is the test. There are no other questions on there. Let me be clear, there are no questions about file IO, which is the module that we've been covering this week. So we will not ask you to do anything about reading in a file or reading in or out from a socket or anything like that. It is solely going to be questions that are focused on what I just described. 1 question from Module 4, which is going to be some form of a definition. 2 questions from Module 5, 1 where you trace recursion, 1 where you write recursion. 2 questions from Module 6, 1 where you trace an exception, 1 where you write an exception. And that's it. So if you know how to do these things, you will ace the test. The questions in this example are probably a little bit harder than the questions on the test because, well, I needed to give you something different. I can't actually show you the quiz or the test questions. So I came up with these this morning, and there you have it. All right, so I will post this test in D2L as an announcement. I will also post this video to my YouTube channel. So if you guys are not subscribed or whatever, go look at, I feel like I'm pitching a YouTube channel, good Lord. Go look at YouTube/Enda Sullivan, and in there you can find this. There's also a link in the D2L shell to my things. Any questions about the logistics or the topics covered on the test from anybody? Easy peasy? Yes. If you said something, I actually didn't hear any of it. How will we know what exception was thrown? Was that the question? So in the slide deck for exceptions, we give you the chart that shows you all of the exceptions that are built into Java and C#. Just familiarize yourself with them. That's really all that it boils down to. I mean, honestly, there's only about 6 or 7 different types of exceptions that are built in that can be thrown. And most of them either boil down to arithmetic problems, so divide by 0 being the common one, or an integer overflowing its bounds, or array index problems where you've tried to access an array or an array list or something that is out of the bounds of it, or a string that's out of the bounds. Those are the other ones. And then the third kind are just going to be like user error, where they type in something that you try to parse. And I guess the fourth kind is IO. So I said 2, and then I ended up with 4. So there's arithmetic problems, there's index problems, there is parsing problems where you're trying to take an integer and make it a character or something, and then there is IO problems, but we're not dealing with IO problems for this test. All right? Yeah? No. Okay. Remember, you still have a quiz that is due this Sunday at 7 p.m. that has nothing to do with this test, so make sure you get that one done as well. And then you guys probably also have a lab and an assignment. On Friday, in in the in-person section on Friday, we will do the remainder of File IO for you guys in Video World. On W01, you guys have already seen that video. So everybody have a good day and good luck on the test. Knock